Hello everyone. Hello everyone. Here we are going to see Unit 20, earliest and latest times. Earliest and latest times. So structure of this unit is objective, introduction, procedure to find the latest allowable time of an event, solved examples, sum up, keywords and terminal questions. First, let's see the objective of this unit. After studying this unit, you should be able to understand the concepts of earliest and latest times and to calculate the earliest and latest time values. How to calculate the earliest and latest time values and to identify the critical activities. To identify the critical activities and finally how to carry out or how to solve the numerical examples. Okay. Next, introduction of this unit. A project manager has the responsibility to see that a project is completed by the stipulated date or day without any delay. Okay. A project manager has the responsibility to see that a project is completed by the stipulated date or day without any delay. First thing is earliest times of an activity. Earliest time of an activity. Let us consider here, let us consider earliest start time of an activity and earliest finish time of an activity. Earliest start time and earliest finish time of an activity. So, earliest start time of an activity is the earliest possible time of starting that activity on the condition that all the other activities preceding to it were began at the earliest possible times. Okay, so earliest finish time of an activity is the earliest possible time of completing that activity. Okay, earliest finish time of an activity is calculated by the earliest possible time of completing that activity. It is determined by using the formula that is the earliest finish time of an activity is equal to the addition of the earliest start time of the activity plus the stipulated, the estimated duration to carry out that activity. Addition of two things. They are the earliest start time of the activity and the estimated duration to carry out that activity. Duration value. We have to add two things. What are they? They are earliest start time and the duration value. And the duration value. Then latest times of an activity. Here we consider that latest finish time of an activity and latest start time of an activity. So latest finish time of an activity is the latest possible time of completing that activity on the condition that all the other activities succeeding it are carried out as per the plan of management and without any delaying the project beyond the stipulated time, not beyond the stipulated time. Then latest start time of an activity is the latest possible time of beginning that activity. Latest possible time of beginning that activity. It is given by the formula. It is calculated by using the formula. Latest start time of an activity is equal to the difference between the latest finish time of the activity and the estimated duration to carry out that activity. Okay, okay. So keep that in your mind that for earliest for earliest time, earliest time. otherwise called forward direction, forward pause, forward direction. Whereas latest means backward direction. And for earliest, add, we have to add the start value plus duration, start value plus duration. Whereas in the latest time, we have to find the difference between latest finish and the duration. Yes, latest finish and the duration. Next one is total float of an activity. Total float of an activity. So float seeks to measure how much delay is acceptable. Yes, total float. Total float means how much delay is acceptable. How much delay is acceptable. It controls the limit for delay. It controls the limit for the delay. So, float seeks to measure how much delay is acceptable. How much delay is acceptable. It controls the limit for delay. It controls the limit for a delay. So, the total float of an activity is the time by which the activity can be delayed without delaying the whole project. Without delaying the whole project. It is determined by using the formula total float of an activity is equal to the difference between the latest finish time of the activity and the earliest finish time of that activity. So what's the formula for total float of an activity? It is calculated by the difference between latest finish time of the activity and earliest finish time of that activity. Okay, one more formula is there for finding a total float. Total float. It is total float of an activity is equal to the difference between earliest start value or latest start time of the activity and earliest start time of that activity. Okay. Either we have to find the difference between latest and earliest finish, or we have to find the difference between latest start and earliest start. Both are right. Okay. So, since a delay in a critical activity will delay the execution of the whole project, in that case, the total float of a critical activity must be zero. Total float of the critical activity must be zero. Then, expected times of an activity. Expected times of an activity. So, an event occurs at a point of time. Let us consider the first thing, earliest expected time of occurrences of an activity and latest allowable time of occurrences of an activity. Two things are there. First thing is earliest expected time of occurrences of an activity. Second thing is latest allowable time of occurrences of an activity. So, the earliest expected time of occurrence of an activity is the earliest possible time of expecting that event to happen on the condition that all the preceding activities have been completed. Then, the latest allowable time of occurrences of an activity is the latest possible time of expecting that event to happen without delaying the project beyond the stipulated time. So, the earliest expected time of occurrences of an event is the earliest possible time of expecting that event to happen on the condition that all the preceding activities have been completed. And the latest allowable time of occurrences of an event is the latest possible time of expecting that event to happen without delaying the project beyond the stipulated time. Beyond the stipulated time. Next one is procedure to find the earliest expected time of an activity. Procedure to find the earliest expected time of an activity. For the first step, for the first step, take the earliest expected time of occurrences of the start event as 0. Okay, in all the problems, we have to take the earliest expected time of occurrences of the start event is as 0. Okay, then second step, for an activity other than the start event, for the activity for an event other than the start event, find out all paths in the network which connect the start node with the node representing the event under consideration. With the node representing the event under consideration. And in the forward pass, that is movement in the network from left to right. Forward pass means movement in the network diagram from left to right. We have to find out the sum of the time duration of the activities in each path identified in step 2. Identified in step. Suppose if we have find 3 parts means we have to sum all the time duration of the activities in each parts. Okay, that is what here. And in the next step, the path with the longest time in step 3 gives the earliest expected time of occurrences of the event. Keep that in your mind. Path with longest time duration. It will give the earliest expected time of occurrences of the event. Then working rule for finding the earliest expected time of an event. So for an event under consideration, locate all the predecessor events and identify their earliest expected times. With the earliest expected time of each event, we have to add the time duration of the activity connecting that event to the event under consideration. So, we have to pick the maximum among all these values gives the earliest expected time of occurrences of the event. Okay. So, procedure to find the latest allowable time of an event. Procedure to find latest allowable time of an event. So latest means backward pass, as we all know that here movement in the network diagram from right to left. So the latest allowable time of occurrences of the end node must be the time of completion of the project. It must be the time of completion of the project. Therefore, it shall be equal to the time of the critical path of the project. Okay. In the first step, we have to identify the latest allowable time. The latest allowable time of occurrences of end node. End node. And in step 2, for an event other than the end event, find out all parts in the network which connect the end node with the node representing the event under consideration. The event under consideration. In step 3, the backward pass, that is the movement in the network diagram from left to right. We have to subtract the time duration of the activities along each such paths. This is the most important thing, and it is the difference between forward pass and backward pass. In the forward pass, we have to add the time duration of the activities, whereas in backward pass, we have to subtract the time duration of the activities. Keep that in your mind. Okay. Then the next step is the latest allowable time of occurrences of the event is determined by the path with the longest time in step 3. In other words, the smallest value of the time obtained in step 3 gives the latest allowable time of occurrences of the event. Okay. So next thing is working rule for finding the latest allowable time of an event. So in that, for an event under consideration, we have to locate all the successor events and identify their latest allowable times. From the latest allowable time of each successor event, we have to subtract the time duration that begins with the event under consideration. The minimum among all these values gives the latest allowable time of occurrences of the event. Okay. Next thing is slack of an event. The allowable time gap for the occurrences of an event is known as slack of that event. Time gap. Allowable time gap for the occurrences of the event is called slack of the event. It is calculated by using the formula difference between the latest allowable time of an event and the earliest expected time of occurrences of that event. Okay. Then solved problems. Problem number 1. The following details are available according a project. First column denotes the activity column, and the second column denotes the predecessor activity column, and the third column denotes the duration in weeks. Duration values in weeks. We have to determine the earliest and the latest times, the total float for each activity, and the critical activities and project completion time. Okay. So from the given data, with the help of the given data, we have to construct the following network diagram. Construct the following network diagram. So, in this network diagram, there are 4 such parts for the given project. They are path 1. Path 1. It beginning with the starting node 1 and stopping with the ending node 8. So 1 to 2 is having an activity A and its time duration is 12. 2 to 3 is having an activity B and its time duration value is 7. And 3 to 5 is having an activity F and its time duration is 10. Then 5 to 7 is having an activity H and its time duration is 14. Then 7 to 8 is having an activity J and its time duration is 16. Therefore, we have to find the time of path 1. It is addition of all these time duration values, that is 12 plus 7 plus 10 plus 14 plus 16. It is 59 weeks. Then path 2, it starts from the starting node 1 and ends with the ending node 8. So 1 to 2 is having an activity A and a duration value 12. 2 to 5 is having an activity B and its time duration value is 8. And 5 to 7 is having an activity H and its time duration value is 14. Then 7 to 8 is having an activities J and its time duration value is 16. So time of path 2. time duration value for path 2 is addition of all these time values. It is 12 plus 8 plus 14 plus 16, 50 weeks. Then path 3, it also starts from the starting node 1 and ends with the ending node 8. And 1 to 2 is having an activity A and its time duration is 12. 2 to 6 is having an activity E and its time duration is 6. And 6 to 7 is having an activity I and its time duration is 14. 7 to 8 is having an activity J and its time duration is 16. Then time duration for path 3 is 12 plus 6 plus 14 plus 16. It is 47 weeks. Then path 4, 1 to 2 is having an activity A and its time duration is 12. 2 to 4 is having an activity C and its time duration is 11. 4 to 6 is having an activity G and its time duration is 9. And 6 to 7 is having an activity I and its time duration is 13. 7 to 8 is having an activity J and its time duration is 16. Then time duration value for path 4. Yes, we have to add all the time duration values, that is 12 plus 11 plus 9 plus 13 plus 16 is 61. Compare the time values for all the 4 parts. We have to pick the maximum. The maximum of 51, 50, 47 and 61. It is 61. So we see that the maximum time of a path, maximum time duration of a path is 61 weeks. Next, we have to calculate forward pass. That is, we have to calculate the earliest expected time of occurrences of events. So for node 1, earliest time value will be 0. For node 2, the time duration for node 1 is 0. I mean, earliest start value for node 1 is 0 and the time duration for activity A is 12. So 0 plus 12 is 12. Then for node 3, the start value, earliest start value for node 2 is 12 plus time duration value for activity B is 7. So 12 plus 7 is 19. Then for node 4, earliest start value for node 2 is 12 plus time duration for activity C is 11. So 12 plus 11 is 23. 23. Then for node 5, maximum of, we have to find the maximum because it is a forward direction or forward pass, right? So we have to add and pick the maximum value. Keep that in your mind. It is a rule. So earliest start value for node 2 plus time duration for activity D, comma, earliest start value for node 3 plus time duration for activity F. So maximum of 20 and 29 is 29. Then for node 6, here also we have to pick the maximum value. So maximum of time, earliest start value for node 2 plus time for activity E and earliest start value for node 4 and time for activity G. Therefore, maximum of 18 and 32 is 32. 32. Then for node 7, again we have to pick the maximum value. So maximum of 43 and 45 is 45. For node 8, earliest start value will be 61. 61. Next we have to find the latest. This table shows the earliest start time of an activities. For activity A, earliest start value is 0. For activity B, earliest start value is 12. For B, C, and D, E, and E are having the earliest start value as 12. And for activity F, the earliest start value is 9. For activity G, the earliest start value is 23. And for activity H, the earliest start value is 29. For activity I and J, earliest start values are 32 and 45. 45. Next, backward pass. So, this table shows the calculation for latest allowable time of occurrences of event. So it is a backward pass, right? So we have to start from the ending node 8 to the starting node 1. Keep that in your mind. Okay, for node 8, maximum time of a path in the network is 61. It remains the same thing. And for node 7, here we have to find the difference between your latest finish value and the duration value. Keep that in mind. Yes, it is the most important thing. So for node 7, latest finish value for node 8 is 61, and the time duration for activity J is 16. So 61 minus 16, it is 45. 45. So for node 6, time for node 7 minus time for activity J, it is 32. So for node 5, latest finish value for node 7 minus time duration for activity H. So 45 minus 14 is 31. Then for node 4, for node 4, latest finish value for node 6 minus time duration for activity G. It is 32 minus 9 is 23. Then for node 3, it is 31 minus 10, it is 21. For node 2, they have four succeeding values are there. So here it is a backward direction. So we have to find the difference and pick pick out the minimum value. So minimum of time for node 3 minus time for activity B, time for node 4 minus time for activity C, time for node 5 minus time for activity D, time for node 6 minus time for activity E. Therefore, minimum of 14, 12, 23, 26 is 12. 12. Okay, for node 1, we have to find the difference between year latest finish value of node 2 and the time activity for A. So 12 minus 12 is 0. If for node 1 latest value will become 0 means then only our calculation will be right. Otherwise we made a mistake in that calculation. So keep this in your mind. Okay, this is the most important hint for you. So using the above values, we obtain the latest finish time of the activities as for J activity, latest finish time value in weeks is 61, for I 45, for H 45, for G 32, for F 31, E also 32, D also 31, for C activity it is 23, for B 21 weeks, for A latest finish time value is 12 weeks. 12 weeks. Okay, so calculations of total float for each activity. Each activity. Activity, first column denotes the activity column, second column denotes the duration in weeks column, third column denotes the earliest start time, fourth column denotes the earliest finish time, next column denotes the latest start time and latest finish time. In the last column denotes the total float column. Total float column. These values are there in the previous tables. And see here the last table. Total float is calculated by using the formula latest finish time minus earliest finish time. Latest finish time for activity A is 12 and earliest finish time for activity A is also 12. So 12 minus 12, 0. Next one, 21 minus 19 is 2. Next one, 23 minus 23 is 0. And for activity D, 31 minus 20 is 11. For activity E, 32 minus 18 is 14. For activity F, latest finish time is 31 and earliest finish time is 29. It is 2. For activity G, 32 minus 32, it is 0. For activity H, 45 minus 43 is 2. For I and J activity, it is 45 minus 45, 0 and 61 minus 61, 0. Okay, so keep that in mind. The activities with total float values 0 are A, C, G, I and J. So they are called the critical activities and the project completion time is 61 weeks. Project completion time is 61 weeks. One more problem is there. The following are the details of activities in a project. So using this data, so we have to draw a network diagram, and what we have to find means earliest start time, earliest and latest time, total float for each activity, and project completion time. Project completion time. So using the given data, we have to draw a network diagram first. And to find the critical path means the longest time duration. Longest time duration. So here in this problem, 3 possible paths are there. Out of 3 possible paths, the maximum time of a path 2 is having a maximum value, so 84 weeks. Then we have to find the forward path, that is earliest start values, and latest finish values for all the activities. All the activities and backward pass. In this table, we have to find the latest allowable time of occurrences of events. And calculation for total float of activity is total float is calculated by using the formula latest finish time minus earliest finish time. Latest finish time minus earliest finish time. So in this table, total float, the activities with the total float value equal to 0 are A, B, D, F and G. Therefore, they are called the critical activities, and the project completion time for this problem is 84 weeks. 84 weeks. And here is the sum up. In this unit, the students are able to understand how to draw network diagram and solving the problem using 3 time duration values. And they have given keywords for you. It is earliest time of an activity and latest time of an activity. Earliest earliest finish time is calculated by using the formula, the addition of earliest start time of an activity and the estimated duration value, time duration value, whereas the latest time of an activity, I mean the latest start time of an activity is calculated by using the formula. The difference between the latest finish time of the activity and the estimated time duration to carry out that activity. And they have given some terminal questions for you. Let's make use of it. Okay, thank you.